Hello and welcome back to NHB Retro. In this video, we're going to be continuing working on the Franklin ACE 1000 Plus computer that I've been taking apart and attempting to refurbish. And in this video, we're going to look specifically at the power supply. If you watched my teardown video of this machine, you'll know that the power supply was significantly corroded on the bottom especially, and then it didn't seem to be outputting the right voltages. So that's the stuff I'm going to try to address, both by painting the power supply. This is it finished, by the way, and also recapping it in an attempt to get the right voltages. And it all goes very well. However, I should say this. Throughout this video, I make a mistake, an error, and it's one that I was fully aware that it could be an error, and yet I made it anyway. And so let's talk about it. So this is a switching power supply. It's, there's technical stuff about what makes it a switching power supply, but the main thing that is important here is that a lot of switching power supplies do not perform normally unless they have a load on them, something that is actually drawing power. And again, I knew this from the beginning. And it turns out this power supply is one of those. And in fact, now that I know that, it's pretty easy to spot. When I checked the voltages, the Franklin runs on the same set of voltages as any other, I should say most other Apple IIs, Apple II clones, and that is +5, -5, +12, -12. When I checked those on this unconnected power supply with a voltmeter, they were incorrect. The plus and -5 were fine, but the plus and -12 were more around in the 6 to 7 range. And this is where I made my mistake. I assumed that meant that this power supply, the 12-volt rails, were not working correctly. And now it turns out that, again, with this particular style of power supply, it will not provide the proper 12-volt rails unless there's a load. Now, in my defense, here's another Franklin power supply. I have 4 examples of these Franklin ACE style computers with power supplies. 2 of them have this style. 2 of them have this style. And then from the Sam's computer guide repair literature that I have, I know that there's actually 2 that look more like this, though I don't know very much specifically about what the differences in those are. And just for reference, here we have the Apple II equivalent of that. Now, ostensibly, these all do the same thing. They all provide in a similar way +5, -5, +12, -12. Now, I had previously worked on these 2 style of power supplies. This one, in fact, a number of them. And these, when you plug them in and you probe them, the multimeter for voltages, they work just fine without a load. And so that kind of set me up for thinking that this one should be the same. And it's not. And yeah, that was definitely my error. So that being said, the rest of this is all very appropriate. And frankly, I ended up replacing all the capacitors in here. It wasn't expensive. It wasn't hard. And there's now brand new Panasonic and Nichicon caps in this power supply. So I don't feel like that was a waste of time, but it was a mistake on my part. You'll see it throughout the video. I figured it out near the end, but yeah, let's get on with the video, and I'll come back at the end and we'll talk a little bit more. All right, power supply. Oh yeah, okay. Significant rust, as we can see here. This definitely got exposed to the elements. So, okay, let's continue looking at the power supply. Okay, so step 1 for addressing the rust issue on the power supply. I'm just going to let this part of it sit in some. evaporust. So let's just get some of this over there till we get enough depth, and then we'll just flip it over so it can really soak. Okay, anyway, I'm going to get that soaking, and then we'll move on to the next bit. Okay, it is the next day, not quite 24 hours later, but some time has passed. Looks like the evaporust has been doing its work. Let's just take a quick look here. Full disclosure, I have been a couple times yesterday. I flipped this over and I used a copper brush to just. There was so much chunky rust on there. I thought it was best to mechanically remove some of it. Okay, and there we have it. So yeah, actually does a pretty amazing job considering how rusted this was. It's going to be pitted. There's definitely pits left over in it. But yeah, so that turned out real nice. So I might sand this a little bit more just to get rid of, there's quite a bit of pitting from the rust. And then I'll paint it with a rust inhibitor, and we'll be good to go. All right, here's the cover. After painting, I just used a anti-rust primer on the whole thing. It turned out really good. It obviously has pits. It was very, very rusted, but yeah, that'll get us done. So next, I want to take this the second half of this shell off here, and do some slightly more minimal, but also just addressing some of this rust that's on here. So let's get that off of here. It's gonna need some various sockets and such. Let's get that going. Okay, with the case mostly addressed, the power supply case that is, it's time to concentrate on the actual power supply board itself. What I'm going to do is I'm going to replace all the capacitors, as I mentioned. My thought was I would just make a high-res printout of a picture and label all the capacitor values as I took them off the board, because I wasn't sure I could actually see them otherwise when they're installed. But I was able to find all the values, and I've got all those capacitors on order, which means next I need to take these capacitors out of here and then just wait for the other capacitors to show up. So let's do that next. All right, so there we go. Got all the capacitors, at least all the electrolytic capacitors, taken off. I skipped forward a bit there to hopefully not bore you guys too much. Just like with most of these simple one-sided circuit boards that power supplies tend to have, it was very easy to get everything off. I mean, the hardest part is just really making sure you're desoldering the right component, because some of these are actually very, very close together. But yeah, they all came off fine. Now I'm kind of wondering if this is going to be successful, because I did test the old ones that were on there with my multimeter, and they were off, but I don't know if they were off by enough. Like, I expected one of them to be just dead or something like that, but none of them were. They were all like within 25% of what they were supposed to be. Maybe they have really bad ESR or other things that I'm not checking. So yeah, fingers crossed. But now let's go ahead and just get the new capacitors put on. Okay, so all the new capacitors are in. That went fairly smoothly. I did discover an error I made. I think these two here and here, these little teeny ones, I actually bought bipolar caps, so I'm just going to go with them and see what happens, but potentially that's a problem. Okay, so to test this, we need to get it back into the case so we can hook up the switch, and then we can go from there. Alrighty, let's go ahead and get the power supply circuit board mounted back inside the case. I found some new clips. They're not quite the same as the old clips, but they're similar height. I think they will work. Let's see if I'm right and get that thing in there. All right, a little bit of a puzzle to get that all together, but in the end it all fit pretty nicely. Those new clips do work. They fit. You know, just a little bit a matter of pushing them around a little bit. Now I did end up replacing the fan that was in here. This is an AC fan. The old one had a cracked housing, and so when it spun, the housing could expand just a little bit and cause some, you know, the edges of the blades would hit the edges of the shroud and it would just cause some noise. So I did put in a new fan. It's a little bit bigger, but I also think it's higher output. So let's just get all these connections hooked back up and we can go from there. Alrighty, we've got the power supply all put back together. Everything seems to fit. The new fan is looking good. Let's plug it in and just give it a little bit of a test, at least see if the fan is spinning up and everything. See if nothing pops or explodes. Yep, got to turn on the actual switch. Okay, looks good. So that's awesome. Let's move on to see what is next. Okay, for testing purposes, I've got the Franklin power supply hooked up to my Ace 100 motherboard that I'm still kind of poking at, though I don't really, I wish I could make more progress on that because it's tantalizing, but I don't really, we'll see what happens in the future. Anyway, different video. So yeah, I've got the power supply hooked up. Let's put in a game floppy and just make sure this is all working. Okay. Okay, and there we are. Seems to be working fine. And I will note in this configuration where I'm actually downwind from the fan on that power supply, it's pretty loud. It doesn't seem that bad when you're on the other side of it, so I'm hoping once it's in the case, that won't really be much of a worry. But in any case, the voltages are working. We just booted from a disk, so yeah, that, as far as I'm concerned, this power supply is now good to go. Okay, that I think about concludes the work that we're going to be doing on this Franklin power supply. Let's take a quick look just to kind of see how we did. Obviously, the major thing that we had to address was the just intense corrosion that was going on, which you've seen in the video, which necessitated me painting this entire case. Now, normally I wouldn't want to paint something that originally wasn't, just for the look, and maybe for conductivity purposes as well. But in this case, yeah, the corrosion was extreme. You can see the pitting that was going on down here still. I did label it just so that people know that I did recap it and I did paint it for corrosion. Now, one of the things I tried to do was preserve the labels because obviously those are historic. In this case, there's an actual serial number. I did an okay job. All I did really was put painter's tape over these and then cut around them so that they didn't get painted, mask them off. In retrospect, I should have de-tacked that painter's tape because these paper labels will have a tendency to kind of strip. And yeah, this foil one really didn't do so well. Again, I could have done better on that. And this one also, you know, if I had de-tacked that tape, maybe this would have come off better. I'm not sure. So yeah, that could have been better. Still not too bad. The look obviously just has changed just because it's primered now. I'm fairly happy with it. I reused most of the original pieces. I replaced things that were broken, the clips, etc. Yeah, all in all, pretty good. Hopefully the rest of this machine goes as well. But I think that's all for now. Thank you for watching, and look forward to the next section of this series. I think it will be on the disk drives. Yeah, again, thanks for watching, and I'll catch you next time.